Hello all, welcome to my engineering physics channel. We are discussing about fundamental of photonics, first part, that is laser. Today's session number is 3. In today's session, we are discuss about some characteristics of laser, some applications of laser and numerical problems based on laser. So let's start the session. So the first part is characteristics of laser. So there are the 5 characteristics for the laser. The first characteristics is monochromaticity. Mono is nothing but the single and chroma, it is a Greek word which is used for color. If the light coming from the source has only one frequency of oscillation, the light is called as monochromatic, and the source is nothing but monochromatic source. So our laser gives us a single frequency light or the single wavelength light. So the laser is highly monochromatic. Now the second property is coherence. In the laser, a large number of photons are emitted through stimulated emission and therefore they are in phase with each other. That means if the light coming from the laser are in phase with each other, then we can say that it is highly coherent. The photon or the light travels in phase for some time and after some time it will become out of phase. This period is nothing but coherence time, and the distance traveled by the light is nothing but coherence length. And this coherence time can be given by the formula del tau, which is equals to 1 upon del nu. And this coherence time for the natural light is 10 raised to minus 14 seconds, and for laser it is 1 milliseconds. Coherence length for the laser is 300 meter and for HANE laser it is 100 meter. Now the next characteristics of laser is directionality. Light propagating along with the axial direction emerges from the cavity and becomes the laser beam. Thus, the laser beam emits a light which is in single direction, or we can say that only in one direction. So, it has the angular divergence which is small, which is nearly equal to 10 raised to minus 3 radians. Next characteristics is divergence. So light from a conventional source is spread over the spherical wavefront, and the conventional source has highly divergent, and but for the light from the laser propagate in a plane waves, that is the bundle of parallel waves, so it has the small divergence, or we can say that the negligible divergence. So this divergence is given by the formula theta equals to square root of d2 square minus d1 square divided by L2 minus L1. So d2 and d1 are nothing but the diameter of laser spot produces on the screen, and L2 and L1 is nothing but the position length. Next important characteristics of laser is intensity. The intensity of conventional light source decreases as the distances increase, but in laser the intensity remains constant as your distance is increasing. That means the laser is a narrow beam, so it has the high intensity. This is all the 5 characteristics of laser. Now we are discussing some engineering or the industrial applications of the laser. So the first applications of the laser is welding. So for the welding purpose, we are using the different lasers. For welding purpose, we can use a ND arc laser, or we can use a CO2 laser for the welding purposes. So in welding method, the two metal plates are welded, are held in contact at their edges, and the high power laser is focused on the line of contact. So the metal at the line of contact melts and solidifies after the cooling, which sticks the two plates together. So this is the actual welding process by using the laser. So this is the welding process diagram of the laser. In this, laser welding is commonly used in automobile industries, shipbuilding industries, aircraft manufacturing industries, and for welding purpose we are using NDAC laser and CO2 laser. Now, next application is cutting. So we can cut some materials by using laser, and which is used as NDAC laser and CO2 laser. The laser is focused on the metal sheet and the jet of oxygen is blown on the spot. A significant part of energy is required for cutting is supplied to the burning of metal. The oxygen jet also blows away and vaporizes the metal and also cools the adjacent edges. So, the laser cutting uses NDAC laser and CO2 laser. Now, the next application is drilling. So, for drilling purpose, we are using NDAC laser. In drilling, the holes can be drilled in the material by using high power laser in the pulses form. The laser pulse evaporates the material which leaves the holes in the place. For example, NDAC laser. The laser drilling has a very high degree of precision and holes can be drilled in any direction. As the laser is focused to very fine spot, the very small holes can be drilled by using of laser drilling of few microns. Now, next application is measurement of atmospheric pollution levels. So, the pollution in the atmosphere is due to the suspended particulate matter like a dust, smoke, flash, etc. And now particulate matter like carbon monoxide, sulfur dioxide, etc. The conventional method for measurement of pollution levels required the collection of sample and the chemical analysis, but it is a time-consuming process. Using lasers, we can get a real-time data by transforming laser beam in the atmosphere and then observing either the reflected and transmitted beam. Now, next is LIDAR. LIDAR is used for light detection and ranging system. So, in which what will happen? The laser beam is incident or it is transferred in the atmosphere and the reflected light beam is recorded in the terms of light waves. So, which is used in LIDAR technique. And it is used to measure the concentration of suspended particulate matter in the atmosphere. So, this is one of the application. Now, in medicals, the laser is used in various surgeries like as the laser is used in eye surgeries as they are focused in very fine spot. It is used to weld the detached retina of our eye. Now, the laser is used for bloodless cancer surgeries. It is also used as painless dental surgeries and it is used in plastic surgeries for treating the skin diseases. Now, moving towards the most important application of laser, that is holography. So, holo means whole and graphy means image. So, in holography technique, we are getting the 3D image of any object. In conventional photography, that is 2D image of an object is formed. But in holography, we are getting the 3D image of our object. So, it is a technique for producing 3D image. Conventional photography consists of 2D image in which the amplitude of light coming from the object is only taken into consideration. In holography, both that is amplitude and phase is recorded in the interference pattern, that is dark and bright fringes. So, the coherent laser light from a laser is incident. So laser is divided into two light waves, that is incident plane wave, which is incident on your object, and we will get a final reflected light at a recording plate. And the second part is incident plane wave on the mirror, and we will get a second reference wave which is in recording plate. So this your object wave and this your reference wave will interfere with each other. That means they will superimpose with each other and produces the interference pattern. And this interference pattern can gives us a 3D image of our object. So this hologram acts as a diffraction grid. Now some technological applications of holography is it uses a 3D image of an object. It is capable for the large amount of data, mainly useful in RAW. One can study the air pollution and measurement of size and velocity of particles. So it is also used to determine the Young's modulus of the material. It is also used to study the 3D structure of microorganism. So this is the all about the engineering and industrial applications of laser. Now we will see some numerical problems based on laser. So the first problem is, if the wavelength of laser is 6550 angstrom, calculate the energy and the momentum of the photon. So they are giving the wavelength which is denoted by lambda, which is equals to 6550 angstrom. We have to convert this lambda into meter. So multiply this value into 10 raised to minus 10 meter. We have to find that the energy and the momentum of the photon. We know the relation E is equals to h nu, and nu is nothing but c upon lambda. So we can write capital E equals to hc upon lambda. Here h is your Planck's constant whose value is 6.63 into 10 raised to minus 34. C is your speed of light, it is 3 into 10 raised to 8, and lambda that is given. So after putting the values, I will get the answer of 3.0366 into 10 raised to minus 19 joule. This is your energy corresponding to our laser beam. Now we have to calculate the momentum of the photon. For calculating the momentum of the photon, we can use the de Broglie hypothesis, that is lambda is equals to h upon p. So by rearranging this formula, we get P is equals to h upon lambda. We know the value of h, we know the value of lambda. After putting that values, I will get the momentum for the photon is 1.012 into 10 raised to minus 27. So this is the momentum of the photon. Now moving towards next. Numerical. The ground state and excited state of laser is separated by 1.8 electron volt. Calculate the ratio of number of atoms in the excited state and the ground state of the wavelength of radiation emitted at 27 degrees Celsius. So they are giving the difference between excited state and ground state, that is E2 minus E1, which is equals to 1.8 electron volt. So we have to convert it into joule. So multiply this value 1.8 into 10 raised to into 1.6 into 10 raised to minus 19. So we will get the energy difference in the terms of joule, which is 2.88 into 10 raised to minus 19. And they are giving the temperature of 27 degrees Celsius. We have to convert it into Kelvin. So we are adding 273. In this value, we will get the temperature in Kelvin. And next we have the K, which is Boltzmann constant, whose value is 1.38 into 10 raised to minus 19 joule per Kelvin. So now we have to calculate the lambda. So for that, we are using this relation E is equals to N0 E raised to minus E upon KT. Therefore, We are taking the ratio of N2 and N1. N2 is excited state, N1 is ground state. We can write E is equals to minus E2 minus E1 upon KT. So we have the value of E2 minus E1, that is 2.88 into 10 raised to minus 19. K is Boltzmann constant and temperature. So therefore this ratio becomes N2 upon N1, which is equals to 6.14 into 10 raised to minus 30. Now we know that E is equals to h nu, or E is equals to Sc upon lambda. So we are interested in lambda. So I will rearranging this formula as lambda is equals to Sc upon E2 minus E1. Putting the value of h, c and E2 minus E1, I will get the lambda, which is 6900 Armstrong. So this is all about the lasers. So here is end of fundamental of photonics first part, that is laser. In next session we will discuss about the fundamental of photonics second part, that is optical fiber. Thank you all.